the function that we're gonna find the limit eventually. If we know the nature of it, it's easier to get the answer or the limit of the function when we have to. The first types of function that we see most of the time would be the polynomial function. For example, the one that you see all the time, like y equals like 2x, or y equals x to the third power, y equals 1 minus x plus x to the fifth, something like this. Because the property of the polynomial function would be you can have many terms, but each term, the power of the x has to be non-negative integer. Okay, going to be the positive integer or the power 0. So it could be either 0, 1, 2, 3, 4, 5, and so forth. Okay, not negative side. If you have y, okay, I forgot to change the color. So if you have y equals x to the power negative first, so this is 1 over x. This function is not a polynomial function. Okay, not polynomial function because the power is not integer, it's not positive integer. Okay. Okay. So for the special case, the polynomial function, if you find the limit, now we still in the limit concept, right? If we know the function type and the function is polynomial function, the one-sided limit of the polynomial function is the same as the function value. So nothing different. Or you can think about the graph. The graph all connected, all smooth. If you look at any particular point, you can find the function value. You can find the limit coming from the left, from the right, and those one-sided limits will come to the same function value. So that's why when you find the limit of the polynomial function, you can treat them like you find the value of the function itself. Okay, no trick, no technique like additional. You just plug it in and you get the number out. Okay, so that's a polynomial function. Now, for different cases, you're gonna get the limit value. Like the first one, this time, if you have the case of the unbounded limit, and we are talking about the limit. Limit is the behavior of the graph, or I would use the informal name as the value of the y as x approaches to the value a. Okay, the limit is the value of the y, or the trend of the function value, what it approaches to as x approaching to the specific number. For this concept, we look for the infinite one-sided limit. One-sided limit, but infinite. Another way we say unbounded one-sided limit. In a graphical way, as x approaches to the certain number, either the left side or the right side, the function value approaching to positive infinity or grows without bound. So that means if you keep going, you're gonna have the graph like keep rising all the way up. Okay, this case is called positive infinite limit because the graph is going in a positive direction, keep going up, and the notation is the limit. Okay, let me clean up. Is the limit of the function as x approaches a from the left. As you see, the graph is on the left side of this vertical line. It's positive infinity. If the graph remains on the right side, but the tail of the graph approaching like positive infinity, we call the right-sided limit equals positive infinity. And similar manner, if the graph is falling down without bound on the left, on the right, the notation as you see, x, the target, the a, but coming from the left side, so negative superscript, okay? Limit of the function as x approaches a negative equals negative infinity because the function value or the y value approaching negative infinity. Approaching negative infinity, or the graph goes keep going down without bound, okay, without bound, or it's called unbounded one-sided limit. There's two situations. And the wrap up for this limit concept, the limit of the function as x approaches a real number a exists, or the other way, you can find the limit of the function f if and only if the two-sided limit, you see no superscript, right? If the two-sided limit of the function equals any real number. It could be a negative number, it could be zero number, it could be positive number, as long as the value you can tell as a real number. And the second conclusion here, the left-sided limit not equal to the right-sided limit of the same function, then the two-sided limit does not exist. Because we already went through some of the examples earlier. And the last part, or the last conclusion, the limit x approaches a, as you see no superscript, is considered a two-sided limit. For this situation, it's going to be the case that you have the value a and both sides approaching positive infinity. See, from both sides approaching positive infinity or grows without bound. And the other case here is going to be the case that you have the point A, and then I'm going to use different area. So for the value A and the graph approaching negative infinity both sides of the line x equals A. So this case, we can name as positive infinite limit or negative infinite limit, but technically you cannot say what is the real number to represent the infinity. You either say the infinity notation or keep it as general as does not exist, because we cannot pick any real number to represent the limit from both sides. Okay, so this kind of the recap of the one-sided limit, the unbounded limit from the left side, from the right side, go to positive infinity, go to the negative infinity. So far, so good. Questions? Okay, so that's just the concept. All right, let's do some example here. You guys have the calculator handy? No. Or you can use the calculator that built in the computer, or go to desmos.com. Desmos.com. I can show you real quick, and that's easy. Have anyone used before the desmos.com? Let me see. This is the one. So this is the website that you can use as a handy calculator, and you can see graph too for some information. So for this problem, if we compute, well, I'll come back to this screen in a bit after I go over. Okay. It's too easy to see me do the work for you, but I hope you understand better if you get to do it yourself and get the same answer as what I did. Okay, now we're gonna see example. What we're gonna do for this example, we're gonna find the values of each following one-sided limit. Okay, as you see the limit notation and the x approaches 3 negative, the function that we have for this problem, x squared plus 3x minus 7, the power of the x squared, power x1 and power 0. So this is a polynomial function. As you identify as polynomial function, we call the one-sided limit of the function as x approaches a negative equals the limit the function as x approaches a positive equals the function value itself. So either the left side, the right side, they all will come to the same value as the function value. To handle this problem, since we know this is a polynomial function, we just plug it in as x. See the target, the a equals 3, even though like coming from the left side, right? So a is 3. So we just plug it in the 3 for the x position. So it's going to be 3 squared plus 3 times 3 minus 7, and get the number out as 9. plus 3 times 3, another 9, and then minus 7. The final answer would be 18 minus 7 or 11. Okay, when you do the work that you have to show me after, you have to submit the work after the exam, use as many space as you like, show the clear work, and at the end, your final answer, just circle it, okay? Make it in a systematic way and in a manageable way. So, and the calculator, if you gonna use the desmos.com, so I'm gonna bring this up. So for this problem, you just type in the 3 and power 2 minus, no, not minus, plus sign 3 times 3, 3 multiplied by 3 and minus 7, and will give you the answer 11. Okay. So this is one of the web tools that you can use along when you work on the problem. But if you have the calculator, that's more than enough. That's perfect.
Are you allowed to use that Desmo on the test?
Yes, you can. I will set up the link that you are allowed to use. Yeah, the certain website that you can use. And also there will be the on-screen calculator that you can use as well, in addition to the desmos.com. Okay.
Yes, thank you.
Oh, you're welcome. All right, so this is the first problem, as we identify the function as a polynomial. All right, the next one, as you see, we have the limit. The a value equals 2, even 2 coming from the right side because superscript positive sign. But the function, again, this function is another polynomial function. We can treat it in the easier way. We just replace the x with the 2. So 2 to the third minus 5 times 2. Okay, 2 to the third, the 2 times itself 3 times. You put in a calculator or Desmos or whatever the calculating device, you will get 8 minus 10. Final number is negative 2, so that's its limit. All right, and then the last one, the 4x squared minus 8x plus 2. The a value equals 0. Again, this is another polynomial function. So we replace the x with the 0. 4 times 0 squared minus 8 times 0, and then plus 3. 0 times anything, you get 0. The answer is 3. All right. To compute, this is how we can handle it. So what's the meaning of it? So I'm going to show you, are you guys okay with computation so far for the polynomial? Just treat it the same as when you find the function value, okay? But now, what does it mean for the graphical way? So I'm gonna bring it back, the desmos.com here, and then show you the function. So the first one, the function, I'm gonna name it as f of x equals x to the second plus 3x minus 7. So we have the parabola graph, as you see the graph here as a parabola. And we look for the limit as x approaches 3 negative, right? The 3 negative, where is the value 3? The value 3 is right here. I'm gonna say value 3. Okay, and the answer we got 11. So I'm gonna type in here. So the function at 3, we got 11. So the order pair, we got 3 comma f at 3. So label. So that's the order pair on the graph. Okay, and now I'm gonna do the screenshot and put in the note to show like side by side the way that we calculate, and also the Control C. Okay, back to the problem. I'm gonna paste it in here. Whoa, okay, too big. Okay, this is for the first one. So to explain a little bit more, the The format of. Okay, for this case, the function is representing as the parabola graph, and then you are going to find the limit, and the point 3 is right here, right there. X approaches 3 from the left, they're coming from the left side. If you trace the graph, see the graph is connected, it's all smooth in one piece. The left-sided limit approaching the same function value, which is the value 11. So in a graphical way, for the polynomial function, the function value, the two-sided limit, the one-sided limit, they all are the same.